Hi there. I want to do a demonstration of the activities I've done with the HP41 interfacing to the RP2040 microcontroller on the Pico board and show you what I've done so far. Showing some statistics. The microcontroller is not overclocked. It's running at 125 megahertz. It uses both cores, so the user interface is running on core 0 and the emulation layer is running on core 1, and it also uses the PIO state machines for the low-level interfacing to the bus. So there is a state machine for the synchronization and also ISA input, data input state machine. So the software is now in its default state, and if I switch the calculator on, you will see a trace almost in real time of the complete HP41 bus cycle. So it's now in sleep. This is quite a lot of information, so what I can do is with my user interface control the tracing. So it now switches off the ROM tracing and it will only trace activities in the non-system ROMs. So these are the peripherals that are loaded. The currently ROM emulation is active in a limited way. So if I do a catalog, you'll only see the David assembler and my own ROM active, which are running in the emulation layer. The rest are system ROMs. And still the emulation is, the tracing is active here, as you can see with all the accesses by the catalog function, but you do not see any system ROM tracing. So I will now turn the tracing completely off, which is a bit easier to read on the screen. The microcontroller memory, the flash memory and the FRAM contain a number of ROMs, which I can show with the user interface. These are not active currently, only the David assembler is active and my own ROM, just to show some of the tools that I have built inside. So first thing I will do is to take a real ROM, put it in the calculator and copy it to the emulator. This is the good old circuits ROM. Circuit ROM is in page 8. So the circuit ROM is a real hardwired ROM, and I will now copy it to the emulation. And the circuit ROM is in page 8. So I will copy it from 8 to page C, where my emulated QRAM is. Execute code and do the move, which actually copies the ROM to the Pico's memory. So this is the end of the move operation. So if I now do a listing of the ROMs, you can see it has copied the circuit analysis to the FRAM, but it's not active here. So I will remove the ROM from the calculator. So what I do now is activate all the ROMs in the user interface by turning the mapping on, and now this is all hardwired, so it's not very flexible at this moment. I have the OS X active, so you have much more facilities, and almost all the ROMs that you see here are now active. So if I do a listing of the catalog of what's inside my calculator, you can see it in page C. It has now the circuit analysis. I also have the possibility to download ROMs, which is part of the Terminator emulation program. So I will trigger the downloading with the file function and use this program to download a ROM. Let's do the games ROM. This is actually the HP41 CL ROM repository, and it will almost be sent. Be sure to send it as a binary file. The controller is very fast, so there is no reason to program a delay. If you want, you can do that. and you can also verify that it's downloaded correctly by checking the checksum of the ROM. So it's now here. This ROM is now in a buffer in RAM, so I will now put it in an empty part of FRAM, and I'll put it in FRAM page 0. So first I have to activate FRAM. Target page is page 1 in FRAM, and I need to enable programming and then actually program the ROM. If I now do a listing of the ROM, you can see that the games is in FRAM, and if I do now a catalog of all the pages, you will see that the games ROM is now in the system in page D. So some information about the user interface. It's based on the work of Thomas. There is a help function. There is help for the ROM functions. There is a menu with printer functions. This is the help of the printer functions that I have. The ROM is already loaded, and it is now like the printer is switched off. I can show that by doing a print alpha. It will say that the printer is off, so I can switch the printer on. In the user interface, and actually this is still an alpha, so I can do a print alpha, and you can see here it prints alpha in the printer simulator. This is Christoph Giesling's really good printer simulator, and it's in the 82143 mode in this case. The printer characters are sent to the user interface for verification and debugging, but it's now running quite well. It's sent to a serial port, which I'm not using, and in this case I'm using an infrared LED and the infrared receiver to connect to the printer simulator. This is, I think, quite unique. This is not the real red eye sending of data. It sends according to the red eye protocol, but it sends the characters for the 82143 printer. So it's not for the real infrared printer, but it works quite well. So I can print a small program. This is a program which is in my own ROM that I use for M-code development. So you can see it prints both in graphics mode. I also have the PPC ROM loaded, and you may remember that there's a program which prints the PPC logo. So it's now sending the data. I have to do a print buffer to actually show it on the screen. And you can see here that it has printed the logo. It prints full graphics. In the terminal emulator you see a bit of gibberish, but this is the data that is actually sent here. In trace mode, so if I press enter, it will press enter. I can print pi. I can push the print button, where you can see that it prints X. It's, as you know, in program mode, if I push print X on the printer, it will enter the print X command in program mode, and that also works well. I can simulate some of the status words, so I can set the out of paper status on. So if I now try to print something or do something, it says that the printer is out of paper. And in the user interface, I can toggle that status again, and then it's not out of paper anymore. Emulation of the two additional extended memory modules is already active. So if I do an MDIR, you can see what is loaded there and how much memory is left. I've copied some PPC-ROM programs in there. I can show extended memory contents. It shows the non-zero registers in extended memory. And if I remove one memory virtually, I now say that it has only one extended memory. And if I now do an MDIR, it will show less memory. And if I now tell the interface there it has only 0 X memory modules, and switch the calculator off, so you can see the off sequence. It is now only tracing the ROM modules that are plugged in, including page 4 for the library 4, which is in here. You can see that. And if I enable the full system trace, you can see the full on sequence. I now have some bad XROM numbers here. The tracing is almost in real time. Sometimes you can see an O here, which means that there is an overflow. There is a buffer between the two cores. The trace is generated, the data is generated in core 1 where the emulation is running, and the presentation and the disassembler is running on the core 0, which is the non-time critical. So if I now switch the calculator off, you can see the trace and finally the power off. Very useful for debugging programs that you write in M code, for example, and just for general information. So this basically concludes the little demonstration. I hope you liked it. There will be some more developments going on, and I will update it when something is in a more stable state. Thanks.